All right, there we go. So today we'll be starting 11.5, which is volumes of cylinders and prisms. So finding volumes, not too different than finding area. We're just adding that third dimension. So first of all, what is a cylinder? What is a prism? There's lots of household objects that resemble cylinders, like cans mainly. So that would be kind of our main example for cylinders. And then prisms can take a lot of different formats. Anything box shaped, like a tissue box or anything like that, is a rectangular prism. Um, there's also triangular prisms. Like if you look at kind of the bottom of the notes here, we see a triangular prism. Basically, any shape or any three-dimensional object that has one shape that kind of runs through it so that the cross section, no matter where you cut it, is that same shape on that face. That's considered a prism. So there's not a whole lot of triangular prisms out there, but if you've had Toblerone before, that's a triangular prism. So yeah, in general, those are what prisms look like, what cylinders look like, and the formula for their volume is the same. It's the area of the base. That's why we have capital B here. It's not just base anymore. It's area of the base. And then that's times the height. And the height that we're considering here is the distance between like the front base and the back base, or the top and the bottom. It's that other third dimension there. So it's the distance between the bases. So looking at this first one, for example, the cylinder, the base is the circle face. So if you can kind of imagine, the bottom is also a circular face. So that distance between the top and the bottom, or the distance between those bases, is considered our height. So if we're going to do find the volume of a cylinder like we are in our first example here, first thing that we know about a cylinder is that the base is a circle. So if we're going to find the area of the base, we need to find the area of that circle. So to find our area of the base, we're going to be using pi r squared, since that's the formula for area of a circle. So in this case, if we look at the circle that we get here on top, the radius is 5, since the radius is that distance from the center to the edge. So we get pi times 5 squared, which you'll probably want a calculator at that point. Pi times 5 squared is approximately 78.540 if we round to at least 3 decimal places. Again, since this is not my final answer, this is not my final volume, please keep multiple decimal places. That way we don't end up with as much rounding error at the end. So keep at least 3, if not more. You're always welcome to keep more decimal places. All right, so that's the area of the base. So that's going to be part of our final answer, but not the whole thing. The other thing we're looking for is the height, the distance between the two bases, the top and the bottom here in this case. This will be our height. H is 12. So now, finding our volume, we know volume, area of the base times the height. So 78.540 times 12. And if you want an even more accurate answer, you can always leave the answer that you get when you type 25 pi into your calculator, and then just go times 12. But either way, this works. What we get is 942.48, which at this point, I'm okay with rounding to 942.5. And this is going to be centimeters. The difference between area and volume is that, in volume we had square centimeters, or sorry, in area we had square centimeters. In volume, we're going to have cubic centimeters because we're having a third dimension on there. So it's going to be centimeters to the third centimeters cubed. That would be our final answer. All right, so that's volume of a cylinder. Let's go ahead and jump down now to volume of a prism. We're going to tackle two different kinds of prisms today. We're going to go rectangular prism and a triangular prism. So starting with the rectangular prism. All right, so our base shape is a rectangle. And on rectangles, if you remember, finding area of a rectangle was either length times width or base times height. Those are the same thing. So for our area of the base, capital B, base times height. Now, on a rectangular prism, figuring out what the base is can be a little bit difficult because any of these faces could technically be the base. I'm going to go with the left and right sides. As long as they're across from each other, they can be your base on a rectangular prism. So to find the area, we may have to kind of play with the dimensions a little bit because they might not all be labeled. Like this one, 4 inches represents this. It also represents this side and this side and this side. So I could move 4 inches over to any of those, which helps a lot because 3 inches down here, if I do 3 times 4, that would be my base times height. So that would be 12. So area of the base is 12. Then the height, or the distance between my bases, is this remaining dimension here, 10 inches, that I haven't used yet. So my height overall of my prism is 10. So now, and which can get a little bit confusing sometimes if you think about there's a height here and a height here. These are different heights. So this one is the height that you're using to find the area of the base. This is the height that you're using to talk about the distance between your bases. So be careful to not get those confused. Because now when we go to find our volume, we're doing capital B, area of the base, times the height or the distance between the bases. So now we're going, all right, 12 times 10, which is 120 cubic inches. And that's my final answer. Okay, so that's one way you can find the volume of a rectangular prism. There is a shortcut way that you can use to find the volume of a rectangular prism. So, shortcut. You can just go length times width times height. You can just multiply your 3 dimensions. I can go 4 times 10 times 3. It doesn't matter which one is which. And we still get 120. But again, it only works for rectangular prisms. So don't try this on a triangular prism or on a cylinder. It's not going to work. Only use it on rectangular prisms, only on box type shapes. All right. So there's the rectangular prism. Last one for today, the triangular prism. And same volume formula. Triangular prism. The base is a triangle. This is a good time to point out that the base is not always on the bottom of the shape, because the bottom of this shape is a rectangle, but this is a triangular prism, so it's whatever shape runs through the whole thing. So this would be my base, and this would be the other base on this triangular prism. So if I'm going to find the area of a triangular base, we have to use our area of a triangle formula. So for our base, or for the area of the base, it's lowercase b times h divided by 2. So if I'm finding the area of this triangle, we have the base and the height right here, 8 times 3 divided by 2. 8 times 3 is 24, divided by 2 is 12. So that's my area of the base. Then my height of my prism is the distance between my two bases. That's going to be this distance right here, 12 centimeters. So my height that I'm using in my volume formula is 12. So now we're going to go, okay, volume, area of the base times the height is 12 times 12, which is 144 cubic centimeters. Okay, so we've covered cylinders, we've covered rectangular prisms, and triangular prisms. Those are all the different types that we've done so far. All right, so go ahead and flip to the next page with me. Once you have this, feel free to pause if you need to get all of the notes. All right, so today's homework is going to involve a bunch of different cylinders and prisms. On the first couple, it will specifically ask you for the area of the base, and then it will ask you for the volume. So on ones like number 1, find the area of the base first, and then multiply it by the height or the distance between the bases to get the volume. Same thing on number 2, figure out the area of the base. Keep in mind, if this 5.5 meters can be brought forward, so don't get the dimensions confused. These are the same dimension. Same thing on number 3. We're looking at a cylinder, looking for the volume. The 12 feet represents the diameter, so don't forget to find the radius first. And then same kind of thing over here. Find the area of your triangle base, multiply by the distance between the bases. All right. On numbers 5 and 6, these might be a little bit more of a challenge. Also, where it has a comma, it should be a decimal point. If the volume is 135 cubic feet, find the missing dimension. So we would have to take 135 and set it equal to our volume equation, which is area of the base times the height. We have to figure out what I can plug in. So knowing that the height here, the distance between the front and back bases is 15, we can go 135 equals b times 15, divide by 15 on both sides, and then take whatever you get and know that the area of the base is 1.5 times x. So take whatever you get here when you divide by 15 and set that equal to 1.5x. Number 6 goes a lot similarly to number 5. And then finally on the back, we've got a couple more. Same kind of thing. If the volume is something, find the missing dimension. On ones like the cylinder, well, we know cylinders, the area of the base is pi r squared. So I'm going 902.75 equals pi r squared times the height. Then plug in what you have. So we have that 5 is the radius. We have that x is the height. So equals pi times 5 squared times x. And then solve for x. Okay. So those are your homework problems 1 through 8. Work through them, help each other out. I will be back on Monday and I'll answer any questions you guys have on Monday. So it's just for as a heads up, tomorrow we're going to continue with 11.6, which is going to be more volumes of cones and pyramids. So again, do your best with these. When I'm back on Monday, I'll help you out with any questions you guys have. So have a great day. See you guys later.